Hi everyone. In this session, we'll discuss worksheet questions based on electrostatic potential and capacitance. Questions are: sphere 1 with radius r has charge q. Sphere 1 with radius r has charge q. Another sphere, radius 3r and uncharged. If two spheres are now connected with thin conducting wire, then the ratio of sigma 1 by sigma 2 of the surface charge densities. Okay. Total charge q is equal to q plus 0, that is equal to q only, total charge. Total charge is q. After connecting like this, their potentials will become equal. V1 is equal to V2. Whenever two bodies are joined or connected, then their potentials will become equal. If you give sufficient time, charges will be rearranged. So this is equal to k dash q1 by r1, k dash q2 by r2. So k dash will go, q1 by q2 will be r1 by r2, that is equal to r by 3r. So rr gets cancelled. 1:3 will be. Now I can get q1. q1 is equal to 1 part out of 4 parts. How 4 parts? This 1 plus 3 is 4. 4 parts of the q. And q2 is equal to 3 parts out of 4 parts of q. Now sigma is charge by its surface area, 4 pi r1 square. Sigma 2, q2 by 4 pi r square is 3r square, 9r square. What about sigma 1 by sigma 2? Sigma 1 by sigma 2 is equal to q1 by q2 into 9 by 1. So q1 by q2 is 1 by 4 into 4 by 3 into 9 by 1. 4 will go, it will be 3:1. Parallel plate capacitor of plate area A is equal to 10 centimeter square, 10 to the power of minus 4. Plate separation D equal to 3 mm into 10 power minus 3. Charge to a potential 12 volts. Now battery is disconnected. A slab of dielectric is placed between the plates. Slab of dielectric inserted, okay, that is ED only, between the plates. Work done on the system in the process of inserting the slab is alpha epsilon naught. Work done is equal to alpha epsilon naught. The value of alpha is. Work done is nothing but change of energy, right? U is equal to half CV square initial. Final value will be initial value by K will be, right? So I can take like this. Initial energy U. Final energy is U by K. So the difference is 2U by K. How can I say like that? That is U of 1 minus 1 by K. U of 1 minus 1 by K. U of 1 minus 1 by K. This is only work done. So the work done is equal to U is equal to half CV square of epsilon naught A by D into V square to 1 minus 1 by K. So now symbols, W equal to half epsilon naught 8. Oh, answer is in epsilon naught only, no? So why should I substitute 8.85 all those? So just epsilon naught. Area 10 to the power of minus 3. Distance 3 into 10 to the power of minus 3, epsilon naught A by D, into V square. V value 12 12s are 144 into 1 minus 1 by 3. This is equal to 10 power minus 3 will go. This is 2 by 3. 2 will go. So 144 by 9 epsilon naught will be there. 9 16s I think. 16 epsilon naught. So alpha is equal to 16. Yes, next. The following figure shows 9 volts battery. Okay. 9 volts battery. 3 uncharged capacitors are connected, each of 1 microfarad each. 1 microfarad each. The switch is thrown to the right side, okay, until C1 is fully charged. then it is switched to thrown to the left. Okay, final charge on C2. Okay, first this C1 will be charged to 9 volts. First C1 will be charged to 9 volts. C1 charged to 9 volts, and how much charge it will go? Each 1 microfarad, right? So Q is equal to half CV. Q equal to CV, that's it. 1 into 9. 9 micro coulomb is the charge up to there. Oh, fine. Now it is connected to the other one. That means source is removed, and this will behave like a source for the C2 and C3. C2 and C3 will be series, and implies their equivalent capacity, effective capacity is equal to, what is the effective capacity? C3 and 1, so 1 by 2, half only, no, microfarad. So this is effective capacity. Now these two capacitors are charged with the 9 microcoulomb, such that all are in series. Now everybody should have same charge on them. So that is common potential is equal to C1 V1, that is 9 microcoulombs, common potential 9 microcoulombs plus 0 microcoulombs by C1 plus C2, that is 1, this is 1 by 2, so it will be 3 by 2, that is equal to 6 9 into 2 by 3, 3, so 6, common potential 6 volts. Now charge on C2 we want, this is common potential, so Q is equal to CV, C value 1 by 2, V value 6, so that is 3 microcoulomb. 1 2 3 is given. Okay, see here common potential formula is C1 V1 plus C2 V2 by C1 plus C2, like that you can, yeah, I did in this way. Next, the following figure C1 is equal to 5 microfarad, C2 and C3 are 10, C1 is 5, C2 C3s are 10, E equal to 20. Initially the switch is connected to point A until C1 is fully charged, afterwards switch is connected to the other side, connected to B. The charge on the capacitor C3, same logic I want to use. This is 10 and 10, 10 and 10, this is 10, this is 10, so combination will be 20. This is 5, this is 5. Now first common potential, directly I will go to common potential, because we did previous question. Common potential is equal to C1 V1 plus C2 V2 by C1 plus C2 is general formula. C1 V1 is 5 into 20 plus 0, they are uncharged, by total is 25. 5 will go 5 times, so 4 volts is the common potential. Now charge on 3 is equal to, charge on 3, voltage will be 4 only, into capacity is C3. What is 4 into C3 is 10, so 4 tens are 40 microcoulomb. Next, a spherical capacitor consists of two concentric spherical conductors. Find the capacitance of the spherical capacitor if the outer radius is 2r and the inner radius is r. Inner radius is r and the outer radius is 2r. Then effective capacity of this combination. Effective capacity of this combination is, for spherical capacitors, capacity is 4 pi epsilon naught AB by B minus A. Whatever is bigger, that you can subtract. This is effective capacity. 4 pi epsilon naught AB R and 2R by B minus A, 2R minus R. R will go, so 2R. So 8 pi epsilon naught R. A conducting wire cross section area A is equal to 1 into 10 to the power of minus 4. Has charge carriers per meter cube. Charge carriers 3 into 10 to the power of 23 per meter cube. A wire carries a current I is equal to 24 milliamps. Then drift velocity is equal to how much? Drift velocity is I by NEA. I value 24 milliamps, 10 power minus 3. N equal to 3 into 10 to the power of 23. E is 1.6 into 10 to the power of minus 19. A is 10 to the power of minus 4. I don't want to waste my time. You can take the simplified value. 5 into 10 to the power of minus 3. Find the equivalent capacitance between A and B. A and B equivalent capacitance. Loops are first. Loops are first. This is C and C parallel. So it will be 2C. Now 2C series. So answer will be C. Now 2C series. So answer will be C. Now this C and this C are parallel. So answer is 3C. Done. Parallel plate capacitor with air between the plates has capacitance C is equal to 12 to 10 power minus 6. The distance between the plates is doubled. D dash is equal to 2D and space between the plates is filled with a substance K equal to 4. Not K dash, K equal to 4. The capacitance of the capacitor will be C dash is equal to how much? Distance is doubled and K is introduced. So I can write C is equal to or C naught equal to epsilon naught A by D. And C is equal to K epsilon naught A by 2D. So K value is 4. Epsilon naught A by 2D. So that is 2 times of C naught. C equal to 2 times. 2 into 12 into 10 to the power of minus 6. C is equal to 12 2s are 24 microfarad. So option A. An infinite non-conducting sheet has a surface charge density sigma is equal to, actually I don't like this, sigma is equal to 7 into 10 to the power of minus 7 coulomb per meter square. On one side, the distance between the equipotential surfaces whose potentials differ by delta V equal to 19.8 volts and the distance D is equal to how much? V equal to E by D, huh? E equal to sigma by 2 epsilon naught sigma by, so delta V equal to E by D we can use E by D, yeah? No, E into D, E into D, sigma by 2 epsilon naught into D, this is E into D is equal to V. So he is asking D is equal to delta V by sigma into 2 epsilon naught. Delta V is 19.8 2 into epsilon naught. Epsilon naught we have to, but he gave that value, no issue. 8.85 into 10 to the power of minus 12 by sigma 7 into 10 to the power of minus 7. Its simplification hardly 0.5 mm. I think so. Yeah. Electric potential due to a space given by phi is equal to phi naught x naught by x and x naught is equal to 5 by x. Phi naught is also 8 5s by x. Find the electric field at, this is electric potential V you can call, then field E is equal to, so E and V relation, E is equal to minus dou V by dou x I cap and so blah blah blah. Here only x coordinate is given, that's why I am doing only x. So E is equal to minus the dou by dou x of 8 into 5, that is equal to E equal to minus 40 1 by x square into I cap, I cap, that is minus 40 by 100 because x is equal to 10. So that is 0.4 with a negative sign into I cap. So option B, option A. What about to negative sign? Okay, this is minus 1 by x square. So that minus, this minus will go right. So plus only correct. Yes, A option correct one. In a region constant potential, the electric field is 0 and there can be no charge inside the region. In a region of constant potential, electric field is 0 and there can be no charge inside. According to Gauss law, charge inside the region should be 0 if electric field is 0. Okay, actually both the statements are correct only, but may not be a correct explanation. So its answer will become B option. Capacitor C1 1 microfarad and charged using 9 volts battery. C1 is removed from the battery and connected to C2 and C3, 2 and 3 microfarad. This is 2 and 3 microfarads respectively shown in the figure. Find the charge on C3. Equilibrium has reached. Find the charge on C3. Equilibrium has reached. Their effective capacity will be 2 and 3, right? So C23 is equal to parallel, so 5 microfarad, and common potential V is equal to C1 V1 9 into 1 plus C2 V2 by C1 plus C2. C1 plus C2 is 5 plus 1 is 6. So it will be 3 table 3 times, 3 table 2 times. V is equal to common potential is equal to 3 by 2. As common potential is 3 by 2, we can go for common potential 3 by 2. Fine. Now that this common potential only for the both. So he wants C3 only. So voltage for 3 is 3 by 2 and Q for the 3 is Q is equal to CV. C value is 3 into V value 3 by 2. That is 9 by 2. 9 by 2 means 4.5 microcoulomb. Microcoulomb means 10 power minus 6 we can have. The equivalent capacitance between A and B is equivalent capacitance. Here this is 3 because they are in parallel. Now this 3 and this 3 are in series. So 3 by 1 will become 1. Again 3. Again 3. So up to here 3 will come. Up to here 3 will come. 3 are in series. 3 are in series. Implies 1 is the answer. Yes, 60 microfarad plate capacitor whose plates are separated by 6 mm. Capacity 60 microfarad and plate separation D is equal to 6 mm. Voltage charged to 250 and then the charging source is removed when a slab of dielectric constant K is equal to 5 and thickness T is equal to 3 mm is placed. Find the change in the potential difference across the capacitor. Change in the potential difference. Okay, charging battery is removed, right? So we can. First, initially, what is the charge Q? Charge Q equal to charge Q equal to CV. C value 60 into V value 250. This is microcoulomb. Initial charge. Charge remains unaltered even on putting dielectric and placing the distance, whatever you do. Next, charge. Okay, capacity. New capacity is equal to Q is only Q dash. Now Q new capacity is equal to epsilon naught A by D minus T plus T by K. This is epsilon naught A. Of course, we have C is equal to epsilon naught A by D. So CD I can write CD by D values are D minus T plus T by K. I will put for that. And now C value 60, D value 6 in mm. So in the denominator also I will take everything mm only. D value 6, T value 3 plus 3 by K value 5. Sixty into 6 by 3 plus 3 by 5. 60 into 2 by 1 plus 1 by 5. 5 ones are 5 plus 5, 6 into 5. So 6 will go 10 times. 10 tens are 100 K. This is new capacity. Now new potential difference is equal to Q by C dash dash. Q value is 60 into 250 by C dash is 100. 0, 0, 0, 0 will go. 150 volts. 100. Let me check. So we shouldn't get panic. Actually, this is correct answer only. He asked change in potential. Change in potential is equal to, we need to read the question carefully. That is equal to V minus V dash. So 250 minus 150 is 100. So answer correct. He asked change in potential difference, not the final potential difference. This is final potential difference. This is change in potential difference. Next. A 100 volt battery is connected across a series combination V equal to 100 volt battery. Series combination of the two capacitors C1 equal to 4, C2 equal to 8 microfarad. Energy stored in the series combination equal to series. So effective capacity is equal to 4 into 8 by 4 plus 8. 4 3 times 8 by 3 we got. So energy stored equal to half CV square. Half C value 8 by 3. V square is 100 square 4 by 3. 10 to the power of 4. 4 by 3 1.33. 1.33 into 4. 10 power minus 2. Any microfarad systems? Yes. That also who will do? I only have to minus 6 and into minus 6 is there. So it is 1.33 into 10 power minus 2. Yeah. Option B. Next. The space between the two large plates filled with material of uniform density rho. Assume that one of the plate is kept at x equal to 0 and the potential at any point x between the plates is given by. So it's filled with a dielectric and we are supposed to find out potential. Here it is the charge is distributed. So field must be linearly proportional as the charge is increasing. That means differentiation of the potential must give field. So B and C are probable answers. In that C is most probable answer. So C is equal to minus rho x square by 2 epsilon naught plus Ax plus B. This is probable answer. Next. Regular hexagon has sides 5 centimeter, has charge 10 microcoulomb. Regular hexagon 5 centimeter side, 10 microcoulomb charge. At each of the vertex, the potential at the center of the hexagon will not be 0. Field is 0 but potential not 0. Why? Because all are same type of charges. 6 times of one of the potential. 6 times of k dash q by r. 6 times of 9 into 10 to the power of 9 into q value 10 microcoulomb 10 power minus 6 by r is 5 into 10 to the power of minus 2. It's a simplification. Why should I waste time? This is the fun. That's it. That is 1.08 into 10 to the power of 7 volt. Option C. Next. 7 will come, huh? Let me check. This 10 power minus 2 will come up. 10 power minus 2. Minus 2, 1, 3. 3, 9, 12. 12, 6, 6. Oh yeah, correct. Next. Potential difference VA minus VB in the given arrangement is equal to shown in the figure. Q is there, minus Q is there. Potential VA is equal to K dash Q by X plus K dash minus Q by X plus Y. And VB K dash Q by X plus Y minus K dash Q by X. So the distances are different. Now you can go for VA minus VB. Just subtract. Then you will get. And K dash Q value must be given, right? Otherwise, how can you have the numbers? Q value should be given. Let me check Q value whether given or not. Yes, actually in the typed book also the numbers are missing. But this is the concept tutus you can do from this. And as per this only you can select the option. It's an incomplete question. You leave like this. Next. Without numbers, you can't do anything. With numbers, you can simplify. Not a big task. Next. A capacitor is made up of a flat plate of area A, and the second plate is made up of a like of structure. Here the capacitors are in parallel. The capacitors are, one is this one is this one, and one is this one. These three capacitors are in parallel. First one is epsilon naught A by D. A is A by 3. This is epsilon naught A by 2D, because this is D and this is D. This is D, this is D. So 2D. This is D, this is D, this is D. Total 3D. This is epsilon naught A by 3 into 3D. Now effective capacity is C1 plus C2 plus C3, because they are in parallel. And the epsilon naught A can be taken common, and D also will come out. It will be 1 by 3 plus 1 by 6 plus 1 by 9. The LCM is 18. 18 3. 18 in 3, 6 6 3 9 2 Okay, this is epsilon naught A by 2. So 11 by 18. A uniform electric field vector E exists along the horizontal direction as shown in the figure. The electric potential at A is VA. At A, VA. A small point charge Q is slowly taken from A to B along the curved path independent. Potential energy of the charge at point B is equal to potential difference into charge Q is the work done, that only potential energy. Okay, so EX will be the potential. So VA plus EX. Actually, in the direction of field, potential decreases. So B potential is low. So Q into VA minus EX should come, right? Yes, because potential decreases in the direction of field, that's why. A parallel plate capacitor is charged by connecting 2-volt battery across it. V equal to 2-volt battery across it. Then disconnected from the battery and glass slab is introduced between them. Which of the following pairs of quantities decrease? Glass slab is introduced between the plates. Okay, battery disconnected. Whenever battery disconnected, remember, whenever battery disconnected, charge whatever existed will be same first of all. Next, potential will become K times, field will become K times, capacity will become into K times, not by K by K. This is into K times. This is capacity. And energy will become by K, because disconnected battery. Disconnected. Maybe wording I used in a different way. Potential becomes by K times, field will become by K times, capacity will come into K times, potential energy becomes by K times. Energy stored and capacity, which of the following quantities decrease? Capacitance increases, right? So first one wrong. Potential energy decreases, energy stored decreases. D option correct one. And second option, charge same. So that one. Electric field and potential of an electric dipole vary with distance r. Electric field, potential of a dipole vary with r respectively. One is dipole at a distance r. Okay, K dash P cos theta by D square minus A square, or D square minus A square cos square theta. So if you take the dipole expression itself, by square will be the potential, and automatically this field will be the cube. So that should be option C. Yeah, electric field and potential. Yes, first one is field, next one is potential. You need to know the formula, that's it. An electrician requires a capacitance of 6 microfarad. Required is 6 microfarad. Potential difference of 1.5 kilovolt. V equal to 1.5 kilovolt. And a large number of 2 microfarads are available. C naught of 2 microfarad with potential can withstand a potential difference not more than 500 volt. Okay. Then minimum number of capacitors required. number of capacitors in a row M, suppose number of capacitors in a row, how many are needed? Desired voltage by given voltage. Desired voltage is 1.5 kilo, that means 1000. So 1500 by 500. So 3 capacitors in a row. They must be in series actually. So 3 capacitors. Then what happens? Now if you connect like this, C0 by M, the capacity will be. But how much desired capacity C I want? So how many such rows I have to put? Number of rows. Number of rows is equal to desired capacity by C0 by M. So this is equal to Cm by C0. That is 6 into M is 3 by C0. C0 is 2. So this will be 9 such rows. Each row 3. So total 3 9s are 27. 27 should come. Option D. If a slab insulating material 4 into 10 power minus 3, 4 insulate thickness T equal to 4 into 10 power minus 3, introduced between the plates of a parallel plate capacitor, separation between the plates has to be increased by D dash is equal to 3.5 into 10 to the power of minus 3 to restore the capacity to the original value. This is increased by, not increased to. And the dielectric constant of the material is equal to K equal to. First one is epsilon naught A by D only. Second one is epsilon naught A by D minus T plus T by K. Now the distance is changed. So I can write this as D plus D dash. Then only it is restored. So epsilon naught A will go. So what we can write, 1 by D is equal to 1 by D plus D dash minus T value 4 mm. In mm only we can do. Okay. All are, this is mm, that is mm, no issue actually. Plus this is 4 mm by K. K value is also, okay, K value we have to find. And D value initial 4 mm thickness. Okay, fine. Increased by initially 4 meter thickness is introduced between. Okay, fine. Cross multiplication. D plus D dash minus 4 plus 4 by K is equal to D. D gets cancelled. So D dash value we have, how much that is? 3.5 mm. All are in mm. I can do 3.5. 3.5 minus 4 plus 4 by K is equal to 0. This is 0.5. So that means 4 by K is equal to 0.5. So K equal to 8. Everything in mm you can do so that you can do fast. The difference between equivalent capacitances of two identical capacitors connected in parallel to that in series is two identical capacitors connected in parallel that are in series is differed by 6. That means C of 2 minus 1 by 2. 2 2s are 4 minus 1, 3 by 2. C is equal to 6 into 2 by 3. 4 microfarad each. 3 points A, B, C. The line AB is perpendicular to BC. Then which of the following holds good? Potential at A will be equal to potential at B, remember. In the direction of field, potential decreases. In the direction of field, potential decreases. So this will have low potential C. So VA, VB, VC. This is actually B. Next, the figure gives this. Which of the following is true in the electric field regions? Okay, this is volts. slope will give you field. Slope will give you field. Slope give you field. So in the A region, field is 0 because horizontal, slope will be 0. B region, slope is there, E is positive. Of course, minus dV by dr we have to take. So negative I can take. Next. In the C region, again field is 0. In the D region, E value positive. I can call. So A and C are equal and EB is less than ED. EB less than ED. So correct one. Yes, option D.